Let me ask you something. Have you ever looked at a system of equations on the SAT and thought, where do I even start? You see two equations, two variables, maybe even a word problem, and suddenly it feels overwhelming. But here's the truth. Systems of equations are not hard. In fact, they are one of the most predictable and most solvable topics on the SAT. The only problem is this. Most students don't truly understand what's happening. They memorize steps, but don't understand the logic. So in this video, we're going to fix that. Not just how to solve systems, but why the methods work. Welcome back to Mind Over Math, where we simplify math and make it make sense. This video is going deeper than anything we've done so far. We'll cover what systems really are, graph meaning, substitution, elimination, special cases, word problems, SAT tricks, and shortcuts. Stay with me. This will completely change how you see systems. A system of equations is simply two or more equations that share the same variables. For example, x plus y equals 10 and x minus y equals 2. Each equation represents a rule, but more importantly, each equation represents a line on a graph. Imagine those two equations as lines. The solution is where both are true at the same time. That happens at the intersection point. That point is the solution of the system. The solution to a system is the value of the variables that satisfies all equations. So if x equals 6 and y equals 4 works in both equations, that's your answer. There are three possible types of systems. One solution when lines intersect. No solution when lines are parallel. Infinite solutions when both equations are the same line. Here's how they look on a graph. First, one intersection point. Next, parallel lines with no intersection. And finally, the same line, which means every point works. Section 3, substitution. Substitution means replace one variable with an equivalent expression. Example, y equals x plus 2 and x plus y equals 10. We already know what y equals, so we replace y with x plus 2. Now simplify. 2x plus 2 equals 10, so 2x equals 8, x equals 4. Then y equals x plus 2 equals 6. You're not guessing. You're replacing y with something equal to it. That's why substitution works. Advanced substitution example. Y equals 2x plus 3 and 2x plus y equals 13. Substitute to get 2x plus 2x plus 3 equals 13. That gives 4x plus 3 equals 13, x equals 2.5, and then y equals 8. Section 5, elimination. Elimination means add or subtract equations to eliminate one variable. Example, x plus y equals 10 and x minus y equals 2. Add them and y cancels. You get 2x equals 12, so x equals 6. Sometimes we need to multiply first. Example, 2x plus y equals 7 and 3x minus y equals 8. Add them and y cancels. 5x equals 15, so x equals 3. Then y equals 1. When to use which method? Use substitution when one equation is already solved for a variable. Use elimination when the variables line up nicely. Word problem example, two numbers add to 30, and their difference is 6. Let x be the larger and y be the smaller. Then x plus y equals 30 and x minus y equals 6. Solving gives x equals 18 and y equals 12. Real-life application. Tickets cost $10 for adults and $5 for children. Total revenue is $100 and total tickets is $12. The system is 10 a plus 5c equals $100 and a plus c equals $12. Solve to find the numbers of adults and children. Graph interpretation is simple. The intersection point is the answer. If the graph shows 3, 4, then x is 3 and y is 4. No solution case. Y equals 2x plus 1 and y equals 2x plus 5. Same slope, different intercepts. The lines are parallel, so they never meet. Infinite solutions case. 2x plus 4y equals 8 and x plus 2y equals 4. These are the same equation, so every point on the line works. SAT traps include arithmetic mistakes, wrong substitution, not checking answers, and misreading word problems. Slow down and verify. Final challenge. Solve 3x plus y equals 13 and x minus y equals 1. Add them to get 4x equals 14. So x equals 3.5. Then y equals 2.5. Systems are not about difficulty, they are about structure. Understand the logic, and everything becomes simple. Subscribe to Mind Over Math. Next video, inequalities. Keep practicing. You're getting stronger every day. Here are your practice questions. Solve them before the next video.